So section 8.3 on page 587 is about operations with radicals. So we're going to be applying most of the same rules that we already know about operations with algebraic expressions. So the only difference that we're going to have now to be clear about what a radical is, especially what like radicals are. So this is the most important part. So remember, we have a radical that is made of a radical sign with an index here. So for example, this is going to be the index, the radical sign, and also something inside, and this is going to be the radical. And you might have another quantity outside of the radical. Let's say that is going to be the coefficient for this radical. So like radicals are going to be those radicals with the same index and the same radicand. So this definition is very, very important because based on this definition, we're going to be able to apply any rule that we know in algebra to do operations with radicals, like for example, adding, subtracting, multiplying, and so on. So I'm going to start with example 1. And we're going to have a lot of exercises to work today because radicals is a very important topic in algebra, and this is one of those topics that are sometimes confusing for students, but the main source of confusion is when they don't understand what a like radical is, what like radicals are. So example 1 on page 588 is about addition. So we're going to add or subtract as indicated. So the first part of this example is 7 radical 2 plus 5 radical 2. So this is an addition of two terms. So this is one term, this is the other term. So the first thing that we need to check for us to be able to add these two expressions is we're going to check the radicals. So you can see here that you have a radical with the index 2. So this is a square root. You have another radical with index 2. And also you have the radicand for the first one is 2. The radicand for the second one is for the 2. So these radicals have the same index and radicand. So that means that they are like radicals. So we can combine them. So when you combine like terms, usually what you do is you combine the coefficients. You work on the coefficients. So the coefficients here are 7 and 5. So you add 7 and 5 and you're going to get 12, and then you just express or you just write the radical. So that's the answer for this first exercise. Then I have another one. I have the square root of 5x minus 7 times the square root of 5x. So you have here one radical. The radical again is a square root. It's just a radical with index 2. The same radical is here, the same index, and also radicands. The radicands are the same. The radicand for the first radical is 5x. The radicand for the second radical is 5x2. So that means that we can combine them. In this case, we have a subtraction. So you're going to work again with the coefficient. So what is the coefficient for the first radical? You're going to see that there is nothing visible in front of the radical, but you know that there is something there. So what is the number that is in front of this radical? You know that is the number 1, right? So you can do this in your mind. You don't need to write it, but I'm doing just for you to see that when you don't see a coefficient, that doesn't mean that there is no one coefficient there. There is one, and the coefficient is precisely 1. So in this case, then the radical is 5x, and you're going to combine the coefficients. So you have 1 minus 7. You're going to get negative 6. That's the solution for example 1. So sometimes to combine radicals, sometimes you have to simplify the radicals first. Okay, so you're gonna understand this once I work example 2. So let me start example 2. So example 2 is on the same page. Example 2 is the following. So example 2 is again adding or subtracting as indicated. So the first part of this example is just 7 times square root of 3 plus square root of 12. So you can see that these radicals are not like radicals because they don't have the same radical. But you can see whether you can simplify any of these radicals to get at the end like radicals. And you can see that in the case of the square root of 3, there is nothing that you can do because 3 cannot be broken in factors getting a perfect square from one of those. But in the case of 12, you can rewrite 12 as the product of a perfect square and a non-perfect square. So when we try to simplify, remember what we are doing is just looking for factors. One of those factors should be a perfect square, otherwise is there is no reason to modify the radical. So we do that because we would be able to simplify a radical containing a perfect square. So in this case, you write 7 square root of 3 plus, and now 12 is going to be broken into parts. So I know that this is going to be 4 times 3. So, and I see that this is a perfect square because you can use also 6 times 2. And 6 times 2 gives you 12, but 6 is not a perfect square. 2 is not a perfect square, so there is no reason to do that kind of breaking. So we look always to get a perfect square after the operation of factoring a radical. So now we're gonna continue writing the radical that I'm not working on. So remember, this is something that the students usually don't do because it's like, what is the reason of repeating and repeating if I'm just working on this part? Do it because otherwise you're gonna forget at some point and you're gonna miss terms at the end of the day. So I'm going to write a radical for the perfect square, and I'm going to write also the perfect square in this way by using the exponent 2. So because 2 times 2 is going to be 4, and then the other radical for your non-perfect square. So now we're going to be able to cancel the radical here and the exponent. So again, I'm going to write 7 times square root of 3 plus, you can see that what is left after canceling things is just 2 times square root of 3. So now you have like radicals. So now you can combine them. So it's just going to be 7 plus 2 is going to be 9 times the square root of 3. So that's the answer for the first part. So let's continue working on the second part of this example. So I have 4 times the square root of 50x minus 6 times the square root of 32x. So I have coefficients for coefficient negative 6, but I cannot do the subtraction yet because this radical is, or the radicand is not the same as this radicand. So I need to work on these radicals. Maybe I need to work on both. So I need to look for perfect square. So 50, you're gonna become familiar with this. 50 can be broken in 25 times 2. Then I have the x here. So that's the first radical. Then the second radical is gonna be 32. So I can write 32 as 16 times 2x. So now I have parts of these radicals that are perfect squares. So I'm going to rewrite those perfect squares in the way I'm going to be able to simplify my radicals. So I have 4. Then I have a radical for my perfect square, which is 5 squared. Okay, I have another radical for the remaining part. So 2 is not a perfect square. X is not a perfect square either. So I'm going to get this radical for the non-perfect parts. Then I have negative 6. Then I have a radical for 16, which is going to be 4 square. So, and then the radical for the non-perfect square. So it's going to be again 2 and x. So then I'm going to simplify the radicals by uh, removing the radical and the exponent at the same time. Don't forget that. The radical and the exponent at the same time. And then you're going to write the rest. So remember, coefficients are multiplying the quantity that is next to them. So in this case, 4 is going to multiply what is left from the radical that contain a perfect square. So what is that? It's just 5, right? Then I have times the radical containing the non-perfect squares. Then the same thing on this side. So I have 6 times 4, then the square root of 2x. So now I can do some operations here. So 4 times 5 is going to be 20 times the square root of 2x minus 24 times the square root of 2x. Then the final steps is just combining these Lie radicals. So I have now same radicand, same index for the radical sign. So I just need to work with the coefficients. So 20 minus 24 is going to be negative 4 square root of 2x. So that is going to be the final answer. So now I think it's time for you to start working on this. Take your time, follow the steps carefully, write all the steps that you are working on. So don't try to save ink or paper. There are a lot of tricks that when you use them for math is a good use. So write everything. If you are not doing anything on one term, write it there. That should be there. And the part that you are working on, okay, do the modification. So every single step now you can see is very important. So you're gonna work now on exercise set 8.3. So this is 8.3 exercise set on page 591. We have a lot of exercises that you're gonna work on because this is very important for you to do it correctly. So I'm going to give you like 10 exercises or 11. So you're going to work on all of them. So we're going to start with the easy ones, and then we're going to end up with the hard ones, but try to work all of them. It's not going to take longer for you to do it all. So the first is number 2. So I have 9 radical 5 plus 6 radical 5. Then I have number 4 is 19 radical 7 minus 2 radical 7. Then I have number 6 is 5 radical 17 minus 11 radical 17. And then I have 8 is 9 radical x plus 2 radical x. Then I have number 10 is a radical y minus 28 radical y. Then we have 14. You have 14 is a radical 3y minus radical 3y. Then 16 is radical 3 plus radical 3. Then 24 is radical 3 plus radical 27. Then we have 26, which is radical 50 minus radical 2. 28 is radical 28 plus radical 63. 30 is 5 times radical 12 plus radical 75. And then I have 32 is 5 times radical 27 minus 3 times radical 18. Then we have 34 is 2 times radical 50x minus 2 times radical 18x. Then we have 38 is just radical 3 plus radical 13. Then finally we have 42. 42 is 4 radical 8 minus radical 128 plus 2 radical 48 plus 3 radical 18. The last problem is very similar to the one that you might have in your exam. So you're going to need to work on all of these. You can leave some for later to do it at home, but the ones I would like to see now that you solve are the ones that are below this line. So these 7 exercises, it is important that you do it now if you want me to check your answers and help you find any possible source of confusion. So I'm going to give you time to do that. We have plenty of time today to work on this, so we're going to continue in a minute. So let's try to solve problem 32. 32 is 5 times radical 27 minus 3 times radical 18. So the first thing is we're going to try to simplify these radicals by breaking the radicals and trying to see whether we can get a part that is going to be a perfect square. So in the case of 27, you know that 9 times 3 is going to be equal to 27, and what is important is that 9 is a perfect square. So I'm going to break then 27 as 9 times 3. So I have my coefficient here. Now, what about 18? 18 can be written as also 9 times, in this case 2, because 9 is a perfect square, 2 is not, but as long as you have one perfect square, we are fine. So now we're going to write the perfect squares by using the exponential form. So we're going to write 3 square and also a single radical for this perfect square, then another radical for the non-perfect square, which is just 3. Then I have 3 here, the coefficient, and then I'm going to write 9 as 3 square again. And finally, I have a radical for the non-perfect square, which is 2 in the second case, for the second term. So now we are able to cancel this exponent and this radical, and also we're going to remove this radical and this exponent. So that's the reason we need a radical containing perfect square. So now we're going to end up with 5 that is multiplying this, and what is left from this simplification is just the number 3, and then we have a radical 3 that contains a non-perfect square. With respect to the other, we're going to have 3 here, then you remove the radical and the exponent, so you end up only with 3 and times the square root of 2. So now we're going to perform the indicator operation. So I have 5 times 3 is going to be 15 times the square root of 3 minus 9 times the square root of 2. Now, you can see that these are not like radicals because they don't have the same radicand. So that's the final answer. We cannot combine these two radicals. So that's the final answer of 32. Now we have 38. 38 is the square root of 3 plus the square root of 13. So you cannot break 3 because it's a prime number. So you need to remember prime numbers. Prime numbers are unbreakable. So prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and you can just find or look for a prime number list in Google or any other source of information. So you can see here that this is a prime number. The radical is a prime number, and also the radical here is another prime number. So you cannot break this number. So there is no way for you to get like radicals in this case. So the answer is that we cannot combine these radicals. So that's the answer. Finally, we have problem 42. 42 is a four-term expression, arithmetic expression, because it's not algebraic. It doesn't contain any variables. So we have 4 times radical a minus the square root of 128 plus 2 times the square root of 48 and plus 3 times the square root of 18. So what we're going to do is we're going to break the radicals. We're going to factor the radicals and see whether we can get a perfect square out of those factoring. So first, 8. A can be written as 4 times 2, and 4 is a perfect square. 128 is going to be 64 times 2, and 64 is a perfect square. Then I have plus 2 times 48. 48 is 16 times 3, and 16 is a perfect square. Then I have 3 and 18 can be broken as we did before as 9 times 2, and 9 is a perfect square. So now let's write the perfect squares by using the exponential form, and also a single radical for all the perfect squares. So for every perfect square. So we have 4 times, and 4 is going to be 2 square. Then another radical for the non-square, non-perfect square. Then I have minus, then 64 is 8 square times radical 2 plus 2 times, and this is going to be 4 square times radical 3. Then I have 3 times, and this is going to be 3 square. That's my radical with a perfect square, and then a radical for the non-perfect square is going to be just square root of 2, or radical 2. So now we're going to remove radicals and exponents at the same time. So I have this radical and this exponent. I have this radical, this exponent, this radical, this exponent, this radical, and this exponent. So we're going to have 4 times 2, which is 2 is what is left after the uh, removal of radicals and exponents, and square root of 2 minus a times square root of 2 plus 2 times 4 square root of 3 plus 3 times 3 square root of 2. So the final step is just combining like radicals. So these, and these are like radicals. So we're going to be able to combine all of these. So I have 8 from here. I have negative a from here. And I have 9 from here. So this operation is going to be the coefficient for radical 2. And then I have only 2 times 4 is going to be 8 times radical 3. So you can see a minus a is 0. So you're going to end up only with 9 square root of 2 plus 8 square root of 3. So that's the final answer for this problem. So I check this work, and so we already added, subtracted radical. Now we're going to multiply radical expressions, and to do that we're going to use the distributive property. And remember, anytime that we are multiplying radicals, we multiply coefficients, and we multiply radicals, and then if we are able, we simplify the resulting radicals. So we're going to start with example 3 on the same page, and this is about multiplying. So we're going to multiply. In the first case, we have radical 3 multiplying radical 7 plus radical 5. So I have this expression, so I'm going to apply the distributive property. So radical 3 is going to multiply both radicals. So I'm going to start radical 3 times radical 7 plus radical 3 again times radical 5. So we multiply coefficients. In this case, it's just 1 times 1 is 1, and we multiply radicals. So 3 times 7 is going to be 21. Then I have again coefficients are just 1 and 1, and the radicands, the product of those radicands is going to be 3 times 5 is going to be 15. Then you check whether you can break any radical in parts, one of those being a perfect square. You see that you cannot do anything from here, so that's the final answer. So now I'm going to work on the second part of this problem. So now we have two-term radical expressions multiplying each other. So I have 3 plus square root of 2. So that's my first radical expression. The second radical expression is 5 plus square root of 2. So I have now a sort of binomial times another binomial. I don't say binomial because these are not polynomials, but it's just for you to remember that we're going to follow a similar approach. So I'm going to write the first radical expression, the first two-term radical expression vertically. So I'm going to write 3 plus square root of 2, and each of those are going to multiply the second radical expression. So I'm going to multiply by 5 plus radical 2. So remember, this is a radical expression and this is another radical expression. So we're multiplying radical expression. So let's do this work. So I'm going to apply again the distributive property here. So I'm going to have 3 times 5 is just 15, and 3 times radical 2. So 3 is a coefficient and square root of 2 is a radical. So you're going to just leave the coefficient as a coefficient and the radical as a radical. Then in the second case, I have another coefficient times a radical, or vice versa, radical times a coefficient. So you're going to have just the coefficient times the radical. So we write first the coefficient and then the radical. That's the proper order. Then the second product is going to be a radical times another radical. So when you multiply radicals, remember you multiply the radicand. So you have 2 times 2 is going to be 4. So now we're going to simplify if that is possible. So I'm going to write a line and I'm going to write these results in a single line. So I'm going to write 15 plus 3 times the square root of 2 plus 5 times square root of 2 plus square root of 4. So you can see here that you have two like radicals, these two, they are like radicals. And also we have a radical that contains a perfect square. This is a perfect square. So we're going to rewrite this one and we're going to combine these two. So I'm going to get 15 plus 5 plus 3. So I'm going to add the coefficient. I'm going to get 8 and the radical is square root of 2. And in the last case, I have to rewrite 4 as a perfect square, which is 2 squared. And in that way, I'm going to be able to cancel the radical and the exponent. So I'm going to get 15 plus 8 times radical 2 plus, in this case, I only get 2 because the radical went away at the same time that the exponent was 2. Did 2. Sorry. So finally, I have two numbers that I can combine. So these are like terms. So 15 and 2 is going to be 17 plus 8 times the square root of 2. So I have another part now, part C. So part C is another two-term radical expression. So 5 plus square root of 7 multiplying 6 minus 3 times square root of 7. So I'm going to write again the first radical expression vertically, and I'm going to multiply each of these terms by the second radical expression. So 6 minus 3 times square root of 7. Then I'm going to apply the distributive property in both cases. So first I'm going to get 5 times 6 is going to be 30. Then I have 5 times negative 3. So this is a coefficient, this is another coefficient, so this is going to be 15. And then I have this radical 7 that cannot multiply. The radical cannot multiply the coefficient because the radical is inside of a radical. Then in the second case, I have coefficient multiplying a radical, so it's going to be 6 times radical 7. And finally, I have radicals multiplying and also a coefficient multiplying to each other. So I have 1 times negative 3 is going to be negative 3. So that's the product of coefficients. So remember, I have coefficient 1 in this case. Now I'm going to multiply the radicals. So I have 7 times 7 is going to be 49, but I need to keep the radical sign. Then I'm going to write this horizontally to see in what way I can simplify this result. So I'm writing in just a single line everything here. So now you can see many things here. So you can see that we have like radicals, and also we have a perfect square under a radical. So we have a perfect square here. Anytime that we have a perfect square, or that we can break a number involving a perfect square, then things are going to be easier because we're going to be able to simplify something. So I have 30 here. Then I have negative 15 plus 6 is going to be negative 9 square root of 7. So I combine the coefficients, I keep the radical. Then I have negative 3 and 49 is going to be 7 square. So now you can cancel the exponent and the radical sign. So we're going to have 30 minus 9 times radical 7 minus 3 times 7. So 7 is the part that remains after this process of canceling radicals and exponents. So then we do this multiplication. So we're going to have 30 minus 21 minus square root of 7. I'm just switch the order of these terms to see that I can combine these two. So 30 minus 29 is going to be 9 minus 9 times the square root of 7. And that is the final answer for this problem. So we're going to work one more example, and then you're going to have another round of problems to solve. And with that, we're going to finish the first section for today, and then we're going to continue with the other section after a short break. So I'm going to solve now example 4. It's example 4 on page 590. So we have we're going to need to multiply. We need to multiply first. We have 2 plus radical 7, and then that multiplies 2 minus radical 7. So let's do that. So you can see, you can check that you're going to be able to apply all the rules, the shortcuts that you have learned so far in this class. So if you remember, there is a special product that when you have conjugates, remember the conjugates, they look like the same. The only difference is the sign in between. So, and that's our case now. So we have the first term is the same for both radical expressions, and the second term is one that just differs in the sign. So in the first case I have a positive radical 7. In the second case I have a negative radical 7. So this is my case where I have the product of two conjugates, or the product of the sum and the difference. So a plus b times a minus b. If you remember, this is going to be a squared minus b squared. So that's what we're going to do. This is my a, this is my b. So we're going to square the first term. That's 2 squared. Then you have always a negative sign, and then you're going to square the second term. So you have square root of 7, and you're going to square it 2. So, and then you simplify things. So 2 squared is going to be 4. And here is the same thing that we have been doing so far. Anytime that you have a radical and an exponent, which is also equal to the index of the radical, then you can cancel the exponent and the radical. It's exactly the same thing. The only difference is that now the radical is inside of the parentheses and the exponent is outside, and before was the other way around. So you have the radical enclosing the parentheses and the exponent, but the operation is the same. So here you have this negative, and then you end up only with 7 here. So what is 4 minus 7 is going to be negative 3. So that's the final answer for this part of the example. Now I have one more uh, case, for example 4, and it's just square root of 5 minus square root of 3, and that multiplies the square root of 5 plus the square root of 3. So again, you see here what we have here. So you have again conjugates, a minus b, a plus b. So these are conjugates. And anytime that you have the product of two conjugates, you can apply this shortcut. So we're going to need a squared, so square root of 5. We're going to square it, and then minus, and then the other term is square root of 3, and we're going to square it 2. So now we can cancel exponents and radicals. So we end up only with the radicands. Remember, the first radicand is 5, the second radicand is 3. So the final answer is just going to be 2. So that's the final answer for this problem. So now you're going to have a lot of exercises because this is important. I want you to learn this very well. So you're going to end successfully this semester, knowing a lot of things that you're going to use later in your future classes. So we're going to work again 8.3 exercise set on page 591. So you have to work 44 radical 5 multiplying radical 3 plus radical 6, so that's 44. Then we have 46 radical 7 multiplying radical 5 minus radical 11. Then we have 48 radical 6 multiplying 7 plus radical 6. Then we have 50. 50 is radical 6 multiplying radical 6 minus radical 2. Then you're gonna work on 52. 52 is 7 plus radical 2 that multiplies a plus radical 2. Then we have 56. 56 is 7 minus 2 times radical 7. And this is going to multiply 5 minus 3 times. 5 minus 3 times radical 7. Then we have 64. 64 is 4 plus radical 7, multiplying 4 minus radical 7. Then we have 70. 70 is radical 10 minus radical 7, multiplying radical 10 plus radical 7. And finally, you're going to have 78. 78 is radical x minus radical 11 square. So work on these problems. Send me your answers by using the chat box, or you can work these problems and send me the answers taking screenshots, getting the PDF files, and submitting those PDF files through Canvas by looking for the corresponding assignment. So in 48 we have radical 6 multiplying 7 plus radical 6. So we're going to apply the distributive property. So you just need to be careful about what you are multiplying. So in this case, first you are multiplying a radical and a coefficient. So you're going to write first the coefficient and then the radical. Then you're going to have a radical times another radical. So you're going to write, you can write just 6 times 6, which is 36, or as you can see, 6 times 6 is just the square of 6. So you can write 7 times radical 6 plus 6 squared. So 6 times 6 is 6 squared, and the radical remains there. So now you're going to have 7 times radical 6 plus, and now you can see here that this radical cancels this exponent, so you end up only with 6, and that's the final answer. Okay, so other way is that you're going to multiply 6 times 6, and you're going to get the square root of 36, and then you look for factors of 36. Those factors can be 6 times 6 again, or it can be 9 times 4, because 9 times 4 is also 36, and the important thing is the 9 is a perfect square, and also 4 is a perfect square. So that might be another way. So let's say that from here you get 7 radical 6 plus radical 36. So now you see, oh, I can factor 36 as 9 times 4. So I'm going to do that. I'm going to write this, the square root of 9 times 4. And you see, oh, this is a perfect square, but this is also a perfect square. It's fine. You can have two perfect squares. So let's write those by using a radical sign for each. So the first one is going to be 3 square, and the second one is going to be 2 square. So now you're going to cancel again radicals and exponents of the same order. Like, for example, this is index 2, exponent 2, index 2, exponent 2. So you get at the end 7 times square root of 6 plus the radical here was 3, the other radical here is 2. Okay, not just the radical, is the portion that was inside of the parentheses that you squared, and so that you end up with only 3 and 2. So at the end, you're going to get 7 times square root of 6, and 3 times 2 is going to be also 6, which is the same answer that we got before. Okay, now we have another exercise. Is 56. So 56 is 7 minus 2 times square root of 7 multiplying 5 minus 3 times square root of 7. So these are two term radical expressions. I'm going to write the first one vertically, and I'm going to multiply each of these terms by with the second radical expression. So then I'm going to apply the distributive property. So here you are multiplying a constant term and another constant term, or a coefficient and a coefficient. So you're going to get 35. Then here in the next step, you're going to multiply a coefficient and another coefficient. You're going to get negative 21. That's the product of negative 3 and 7, and also a radical. Then you have here negative 2 is the coefficient and 5. So you get negative 10 and also the radical that usually goes after the coefficient. And finally you have negative 2 times negative 3 is going to be positive 6. So we are multiplying coefficients first, and then you multiply radicals. So you have radical 7 times radical 7. So it's like having 7 times 7 under the same radical. So now I'm going to write everything in a single line to see better whether I can simplify something. So I have 35 minus 21 square root of 7 minus 10 square root of 7 plus 6 times, and then I have 7 times 7 is 7 square. So in the last case you can just cancel this and this, so you end up with 35 minus, then you have here two like radicals, so they have the same radicand, they have the same index, so the only difference are the coefficients. So I'm going to combine these two coefficients. I have negative 21 and I have negative 10. So you are combining two negative coefficients, so you're going to get 21 and 10 is 31, and it's negative because both are negative. And they are multiplying square root of 7. Now in the last case, I have 6 multiplying something that is left after you remove the radical and the coefficient. What is left is just 7. So you have 35 minus 31 times square root of 7 plus 42. Then you're going to add 35 and 42. So you get 77. And also you get negative 31 square root of 7. So that should be the final answer for this problem. Okay, any questions so far? So I have one more problem that is from Juan. Okay, so let's work one more problem. So that problem is 78. So let's copy 78. Okay. So 78 is just square root of x minus square root of 11 square. So that's problem 78. So there are two ways to do this problem. You either expand this square, and by expanding the square I mean that you're gonna write square root of x minus square root of 11 that multiplies itself. So it's gonna be square root of x minus square root of 11. Or you can use a special product rule. So I'm going to do it both ways, and you're going to see that you're going to get the same answer. So this is expansion. This is expanding the square. I'm expanding the square. Okay. So this is just the product of two-term radical expressions. I'm going to write the first one vertically, and I'm going to multiply each term and the second radical expression. Okay, so let's see, we're gonna get from the first one. So we're gonna apply the distributive property here. We apply the distributive property here, and we're gonna apply the distributive property also here. So let's see, we have a radical times another radical. So we have x times x is gonna be x squared. Then I have a radical times another radical. So coefficients are just 1 times negative 1 is going to be negative. And then you get 11 times x inside of the radical. So that's the product of the radicands. Radicand x, radicand 11. So you just write it in the proper order. First the coefficient, then the variable. Then you're going to have the same thing here. So you have a radical times another radical, and first the signs, negative times positive is going to be negative, and then radical times another radical, you multiply again radicands, so 11x, and you write first the coefficient and then the variable. Then I have in the last step, I'm going to multiply again two radicals. Negative times negative is going to be positive, and then I have my radical sign, and I'm going to multiply radicands, 11 times 11. If you multiply 11 times 11, you're multiplying 11 by itself. So it's going to be 11 squared. So now we're going to write this in a horizontal way. I'm going to write the square root of x squared minus the square root of 11x minus the square root of 11x plus the square root of 11 squared. So now we can cancel radicals and exponents. Here you have a perfect square that cancels with this radical, another perfect square that cancels with this radical. And also you can see these radicands are the same, the indexes are the same, so that means that these are like radicals. So we can combine those two. So From the first radical, I'm going to get only x. That's what we obtain after removing the exponent and the radical. From these two like radicals, I'm combining two radicals that are negative, so it's going to be -1, -1 the coefficient, so it's going to be -2, then the radical, 11x. Then I have plus, and then what is left from removing the exponent and the radical is just 11. So that's the final answer, because you cannot do anything else. You cannot combine 11 and x, or you cannot break this radical. So that's one way to do this, by expanding the square. The other way is going to be by applying a special product rule. So I'm going to write the original problem, which is the square root of x minus the square root of 11, and we're going to square this. So you can see here that this is your a minus b, and we are squaring a difference. So if you have somewhere your formula sheet, you should have something like this: a squared minus 2 times ab plus b squared. So it's good. It would be very good that you have your formula sheet at hand, because you might need it to use it from now on. So what is a? A is the square root of x. So I'm going to square that. I'm going to write this expression here just to simplify or to visualize better what we're going to do now. So a squared, what is a? A is square root of x, and that is going to be square. Then I have minus 2 times, and then I have the product of a and b. So is a is the square root of x, and b is the square root of 11. Then I have plus b squared, and b is the square root of 11, and we're going to square that. So now we're going to be able to cancel again exponents and radicals, and see that now the way that this expression is written is kind of similar to the way that this other expression is written. So the only thing is that in one case the radical is enclosing the square, and in this case the square is enclosing the radical, but the operation is the same, and the way that we simplify is also the same. We can cancel an exponent and a radical with the same index, and the same thing here. You can cancel this exponent and this radical. So we only need to write what is left. So from the first simplification, we're going to get x only. Then we have the product of two radicals. So the coefficient stays outside, and the radicals multiply to each other. So we're going to have a single radical sign for both, and you have x times 11 is going to be 11x. We need to write first the coefficient and then the variable, and finally you have plus, and you're gonna just write what was left from the last simplification, which is just 11. So that's the final answer. So that's problem 78 solved by two different ways. So now you have some other exercises to work on. So submit everything through Canvas by getting a PDF file and using the submit button. And we're going to continue the next class with the next section. So that's all for today.